Let's keep crack-a-lacking here. Problem number 9. The graph of f is shown. Here's our function. We need to graph f prime and f double prime. All right. Well, take a look at this right here. I mean, f of x can actually be derived right now, even if you don't want to sketch. I mean, wouldn't this just be the equation of, let's see, it has a y-intercept of -2, and look, it goes down 2 over 2. So really, we can just say that this is negative x minus 2. I mean, that's what this equation is. And so if I say, okay, well, now find f prime, well, that's just going to be -1. And then f double prime, of x, that's going to be 0. So basically, we're just graphing y equals -1 and then y equals 0. And then we'll be done right there. So maybe I'll first graph y equals -1. Okay, so it's going to be this guy right here. And so that will be our f prime. And then if you want to do f double prime right here, let's see, maybe I could use this cool dotted line right here. That would be this guy right here. That would be our f double prime. Okay. And again, maybe if you didn't take that kind of approach, you could have just said, oh, but this looks like maybe like it has a slope of like -2 or -1 or something like that. So again, these are sketches, but you should have 2 horizontal lines or never the least there. Okay, so this one's actually better here because it actually forces us to sketch it because they don't cross that nice point where we can derive f of x. So all right, so if this is our function f, we know that where f has a horizontal tangent, which is right here, we know that this is going to be a 0 of our prime. So we know that our f prime is going to have a x-intercept at 2. And let's see here. This right here looks at the x point right here, -1. I would probably say that this has a slope of about like -3. So I'm going to kind of go like this and say, okay, about -3. If I go to right here, okay, maybe like it has a slope of like -1/2 right here. Okay, or maybe like -1.5 or something like that. And then if I look at this slope right here, well, it's, I don't know, maybe like 1/3 or 1/4. So I'm going to kind of go like this. And as you can see here, we have a line going across right here, and I want this to be straight, so I'm just going to kind of do my little sketch here using my cool little thing here. So like I know that it's going to have to go through 2, so I'm going to kind of go something like this then. Okay, against a sketch, this is what our f prime will approximately look like right there. So this will be our f prime. And well, since this is a straight line, or we know that this has a constant derivative or a constant slope. So I'm going to say that this slope right here is like about like 1 or 2. Maybe like it has about a slope of 2. And so that means my derivative then would be a horizontal line at about like right here then. Okay, that would be my f double prime. Okay. Going on here to number 11. We want to find a number of things here. First of all, find the velocity at any time on this line right here. So the way that we find derivative, or the way that you find velocity, is that's what the derivative is. And what's cool, that's the fundamental thing that we learn about the derivative is the change in your rate, right? So let's just go ahead and take the derivative of this. Oh, what's this all about? You go away. Okay, thank you. So let's just go ahead and find s prime of t. Hold on here, having technical difficulties. We'll be right back after these messages. Okay, here we go. So s prime of t would just give us a -2t plus 12. Okay, so I just took the derivative of this, and that's it. That's the velocity at any point on this curve right here. Now identify the intervals when the particle is moving in a positive direction. Okay, well, let's actually find out where it changes, and then we can go from there. So let's find the critical points. So 0 equals -2t plus 12, minus 12. And I'm going to divide both sides by -2. So 6 equals t. And conceptually, what that means is at the point 1, 2, 3, 4, 5, 6, that's going to be our vertex. Because if you look at this right here, I mean, this is a quadratic that's going upside down, right? It looks something like this. Okay, so this is not drawn to scale. And that's for Chris right there, because I know that he would probably say, wait a minute, it probably doesn't even know. I mean, I know it doesn't cross right here, but what I'm just trying to tell you right now is that this 6 represents the x-coordinate of our vertex. It's our maximum, right? So if we're looking for identify the positive intervals, well, does it kind of make sense that time, okay, if this x-axis is our time, then it's only going in a positive direction starting from 0 and then going up from there. So this would be our little interval where it's positive. So from 0 to 6. Yes, I know that it is continuing down here though, but time is never negative. We don't say -1 time or -3 times. So our interval is going to be from 0 to 6. Okay, that's going to be the interval from which it's going to be positive. And you know what? I need to make those not brackets, but parentheses. And the reason why that they need to be in parentheses is because at the actual time, we don't know that could also be in the negative direction. So we're going to say, because it's not changing directions like up here, right? So I'm just going to say from 0 to 6 there. Going for the C now. Identify the time intervals when the particle is moving in negative direction. Well, doesn't that make sense that it's going to go from, where it's going to go from here when it goes down here? So really we're only looking at then from 6 to infinity. That's it. It's going to move in a negative direction from here. See how negative, 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 negative. Basically our graph is moving in a negative direction right there, okay? Identify when the particle changes its direction. Well, it changes its direction at 6, right? And so it's going to be at 6, right here. It changes right here when it gets to our vertex. All right, good. How much time do we have on this video? Oh, only 7 minutes? Let's just keep going on then. Okay, so we have a function right here. Find the critical numbers. All right, so that means we find the derivative and then set it equal to 0 and solve. So let's find the derivative. Okay, so we get 12x squared minus 60x. Set this equal to 0. I'm going to go ahead and factor this right now since I have it right there. I'm going to go and take out 12x. So I get x minus 5 equals 0. Set this equal to 0. I get x equals 5. Set that equals 0. I get x equals 0. So those are our two critical numbers. Now, find the open intervals where the function is increasing and decreasing. Well, we find those intervals out using our critical numbers. So I'm going to divide this into 3 sections. I have a 0 right here, x equals 0, and an x equals 5. So I want to know what is happening to the left of 0, what's happening to the right of 0, but to the left of 5, and what's happening to the right of 5. If we look at their signs, they're going to tell us when our function is increasing and when it's decreasing. Okay, so I need any number that's to the left of 0. How about -1, right? So I'm going to plug in, not into my original function, but into my prime. I'm going to plug in -1, and all I'm interested in is a sign. Well, if I plug in -1 right here, -1 is going to be positive. -1 times -1, well, that means this whole thing is going to be positive right here. Which means then it's increasing. It's increasing from all the way over here, which is -infinity to 0. Okay, so that's when it's going to be increasing. Well, what's happening between 0 and 5? Well, let's just maybe plug in 1. Okay, so if I plug in 1, right here, that's 12 minus 60. Well, that's going to give us a negative value. So that means in between 0 and 5 is going to be negative, which means that it is decreasing from 0 to 5. Okay, and last but not least, what happens past 5? Well, let's just do like 6 then. So f prime of 6. If I do 6 squared and multiply that by 12, that's going to be bigger than 6 times 60. So that means this is going to be a positive, which means that it's increasing from the interval of 5 to infinity. Okay? So increasing from these two intervals, negative infinity to 0 and 5 to infinity, and is decreasing from 0 to 5. Last but not least, let's apply the first derivative test to identify all the relative extrema, meaning plug these guys in, right, and find out what's our max and min. So if I plug in 0, right, if I plug in 0 into my original function, I get 6. And if I plug in 5 into my original function, I get, let's see, negative 244, which means that this is my maximum and this is my minimum. And we'll finish off here with one last video.